Okay, I want to write a two-column proof and prove that my little segment PQ is congruent to that other little segment RS on here. Okay, I've already got my givens written down, but I'm trying to prove that this is congruent to this. And from my given, it doesn't give me a whole lot. But we know that we can change congruence to equals right away, just like what we've done before. That will help us write some equations. So let's do that first. Okay, we're going to change congruence to equals. So we're just going to state that PR is equal to QS by the definition of congruence. Okay, that is step 2. Again, that doesn't give us a whole lot, but I'm really done with statement 1. I've used it, I've come up with the statement 2. Now we'll try and use statement 2 somewhere along the lines. Okay, I would look, okay, and PR it's really got 3 points on it, P, Q, and R. You can see that up in my picture. Here's P, here's R, and I have a Q that's in the middle of it. So given that, let's actually make that so we use the segment addition postulate. Let's say that each little portion together equals the whole thing. Okay, so I'm going to state then that PR, that segment, that whole thing, PR, is equal to my little portions, PQ plus QR. I did it for one, let's do it for the other one. Again, I'm just going off of what was really given to me. Here's PR. I want to do the same thing for QS. That's why I'm deciding to do these, because it's up there in the given. Okay, so we're going to do it for QS as well. Let me erase the picture. And I want to do it for this portion now, QS. Okay, well, I'm going to use the same number here. I'm going to do it for the same step because it's going to be the same reason. So now I have QS, the whole thing, is equal to QR plus RS. And we just use the segment addition postulate. Go ahead and write that down. Segment addition postulate. Okay, so then number 4. I really haven't used either of 2 or 3 combined yet, so let's do that. Okay, I know that PR equals QS. Well, since they equal, here's PR and here's QS, if these two things equal each other, then the right sides should be equal to each other. So let's put those together. Let's use both statements 2 and 3 to come up with statement 4. Let's state then that PQ, my right sides over here, this side and that side are equal to each other. PQ plus QR is equal to QR plus RS. And all we did was we substituted. We just substituted them together. Substitution. Because they're both equal to each other. Okay, so there's statement 4. We'll go to statement 5 now. And I'm just going to use number 4 to help me with this. Well, look at it for a little bit. I see a QR on the left, and I see a QR on the right. Those two things should have the same length. They're the same segment. QR is equal to QR. So if I subtract away QR on both sides, those two things will cancel each other. So let's state that. Let's say we subtracted QR on both sides. Well, if I subtract QR on both sides, I'm just left with PQ on the left and RS on the right. And technically we use the subtraction property. So I'm going to say subtraction over here. And I'll go back up to the top here. We're very, very close now. I've got PQ equals RS, which is what I wanted, except instead of equals I want congruence, so we're going to change it one last time. We're going to state then that PQ is congruent to RS. And we can change that back again because of the definition of congruence. And that's the finished product of our proof. I got from my given to what I was actually trying to prove.